Looks like we have started the stream. Make sure that the stream is started. So I'm going to check that out as we let some people wander in here. Oh boy, what the heck is that? Why does it look so different? Layout controls. Nice. Wonder why that changed. All right, looks like that's working. That's working. Do we have people watching? Wait, there's volume. That's working. Yep, nice. We got volume. Everything's looking good. PS1 equals that. All right, hopefully, I think it's working. Okay, cool. Good afternoon. Well, good afternoon to you. Let's jump into this module. So we are on the reverse engineering module. Wait, is this thing following me? Probably doesn't need to follow me because I'm just sitting here, but we'll make it follow anyways. We're on the reverse engineering module, CSE365, spring 2024, and this current assignment is due in 7 days, 9 hours, and 25 minutes. So what is that? Tuesday night, next Tuesday, week from tomorrow night, or no, week math. A week from tonight? I don't know. It's in 7 days, 9 hours, and 25 minutes. So we are looking at a couple of topics here. We're looking at GDB, debugging refresher, and reverse engineering a whole bunch of different types of programs. All right, good. We've got some questions. That was going to be my next thing. I'm going to say, so does anyone have any questions? Here's the question I see. How do you forcibly skip past a function call during program execution? My approach, set rip equal to the instruction address after the call. For example, scanf. Okay, so there's kind of a number of things going on here. Let's go ahead and make ourselves a nice example program to demonstrate this. cd reverse rm test that test till test that. Okay, and then let's do touch example.c example.c open int main, and we'll say void foo. This thing will print hello world, and we will call foo. Very nice, simple program to talk about this skipping past a function call. Okay, so then let's go ahead, gcc example.co example. Well, it works. Example, yep, works. Okay, let's GDB this. So I like -q. -q makes it so all that intro text doesn't appear, right? If I do without -q, we got all this like garbage text. And then also one other thing I have is I have this .gdb init file. And this .gdb init file, currently it's very simple. It just does fet disassembly flavor intel so that whenever we disassemble instructions, we're seeing intel. So let's go ahead and run gdb-q example. And if we start this up, we're going to be broken at main. So if we display /8i RIP, we're seeing 8 instructions. Every time the program stops, we are seeing 8 instructions. So the question is, how do you forcibly skip past a function call during program execution? So there's a few contexts and few kind of ideas here. So if I break here at this call, so for example, I break at main plus 13. Oops, that is not the right syntax. Star main plus 13. And we continue. Well, now we're about to call foo. So let's say I want to forcibly skip past a function during program execution. So in this context right here, if I don't care what's going on in foo, like I just It's not part of my reversing effort. I think I already understand it. It's just irrelevant to me right now. I can type NI instead of SI, and that's just going to step past it. So NI will just, it's going to execute the code, but it's going to automatically break right at this move EAX0. So if I do NI, we will see we printed hello world, and we're just looking straight here at this thing. So that's one kind of meaning of forcibly skip past, depending on exactly what you mean here. A different meaning though, and if we continue again to right here, so let's say I do SI instead of NI. So step versus next, they sound very similar, and they are very similar. It's just one goes into the call, the other one does not go into the call, it just goes past the call. NI goes past the call, SI goes into the call. So SI, we type this, now we're inside of foo. Let's say I'm now currently executing inside of foo, which we are, and I want to forcibly go past it here. Again, sorry by skip, I meant I don't want to execute the syscall. Well, we'll just quickly show this just to make sure this is clear. And maybe you've never seen this. I can type finish, and finish is going to kind of just finish this function call. It's going to go all the way to the ret and execute that ret. So finish, and suddenly we're back outside of main. So you're saying, sorry, by skip, I mean I don't want to execute the syscall, meaning I don't want the program to ask me for input if I'm using scanf. Okay, great. So you're meaning like literally alter the control flow of this program to literally like not just break after it, like have a breakpoint in some sort of way past what we're looking at, but we want to actually just not even execute that code. So we can do that as well. So I think you already explained one way of doing this, and I'll show you another way that maybe is really what you're looking for. That's a little more, well, it's a different approach. We'll see. So the first way, as you said, is let's say that I continue up to this breakpoint. And I really just don't want, for whatever reason, I don't want the behavior of foo to ever execute. It's not even that I just don't want to analyze it executing. I don't want it to execute for whatever reason. So for example, in your case, you're saying, I don't want it to ask me for input if I'm using scanf. And there might be various reasons, especially in these debugging refresher challenges. There's going to be a point where it like asks you like what's the random number like 100 times, and maybe one way that like you think about handling that scenario of like, hey, how do you start getting into GDB scripting and you start wondering like, hey, how do I send input? And one natural answer to that is like, well, let's just skip the thing that asks for input. And the way that you could do that as an example, and the example you went with, is that I can do set RIP equals this address, right? I think this is the right syntax. We'll make it right if this is not the right syntax. I just want to not even execute this code. I just want to go right to here. And what I'm going to execute next? Well, what I'm going to execute next is whatever the heck RIP is, right? If I look at RIP, it is this address. I'm going to execute this call instruction. Well, let's say I don't want to execute that. I want to execute this. So I do set RIP equals this. And now if we look at RIP, right, we've changed the value of RIP. Now if I look at 8 instructions, we can see we're no longer looking at executing this. We're looking at executing this. And if I step an instruction, right, like this truly did happen. We skipped foo. You'll see nowhere on here do we say hello world. That code just got skipped. So that is one route. Now, another route is, let's say this part of whatever I'm wanting to do. So I'm speaking very generally here because really it depends what's our objective here. And I mean, some of like what our objective is going to be informed by what we're trying to do. So let's say that for some reason, I want to never write to standard out, right? Or let's just say I never want to write. So one thing I can do to skip writing is I can type catch syscall write. So if I do this, so this is similar almost to a breakpoint, is just way more generic. It's going to break before a write syscall happens. And let's go ahead and start up the program again. And we will go ahead and continue. Well, so the first thing we hit was our breakpoint. So if I do info B, we can see we've got a breakpoint set here at main plus 13. And we've got this syscall write kind of catch point. Similar to a breakpoint, it's a catch point. And we continue here. Okay, so now I've paused at a different spot, and this looks like a little bit of a mess, and it's partially because my text is so large. Where are we? Well, okay, one way of answering that question of where the heck are we is if we type BT. So BT means backtrace. If I look at this backtrace here, I can see that currently, right, there's like a call stack, like something called something called something called something. I am currently in underscore underscore GI underscore 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 libc write, which the person who called libc write is io new file writes, and the person who called io new file write is new do writes, and the person who called that, well, we had something going on here. IO new do write, IO new do write, IO new file overflow, GI IO puts, foo main, right? So main called foo, which called puts, which called this thing, which called it, right? It's this whole chain. Like someone's calling something, calling something, calling something. And eventually we end up right here where, well, actually, if we look back to, we can see right here, right, inside of this GI underscore libc write, this is the function that does the syscall instruction. And, it's a little bit unfortunate how zoomed in I am because it makes it hard to see what's going on here, right? Here's an instruction. This is the next instruction. So right now, this is the instruction we're about to execute. So this is that syscall. Okay, so that is what we're looking at right here. And I think if we do SI, I'm pretty sure at this point we're going to execute the next instruction, which is that it's pointing a little bit differently. It has to do with how this catch point works. I think if I SI, we're going to see hello world pops out. Yeah, hello world pops out. So this is the idea of a catch point, very similar to a breakpoint, but instead instead of pausing execution on some specific instruction, we're breaking every time we're about to do a syscall. So let's start again from the beginning. And I'm thinking about maybe decreasing the font size a little bit, actually. Open user settings, font size, terminal font. Okay, let's try 28. Okay, let's continue. And then let's continue. It still isn't super nice. 24. See, it's like, oh, maybe it works. What kind of works? I want like the address to be, right here. Yeah, we'll roll with this for now. Right, 24. We'll go back to 32 as soon as we can. It's just this long instruction. Like I don't know how to disable printing this, but whatever. This is what we're rolling with. Okay, so this looks like a bug in GDB. Honestly, the fact that it says it's pointing here, right, that it's pointing to this, I don't think that's true. Pretty sure it's pointing to this because we haven't actually done the syscall yet. So that's a little bit of a lie. In fact, what does it say? Yeah, I'm not convinced because as we saw before, if I do SI, that's when the syscall actually happens. So unclear what's going on there. let's go ahead and, so we saw that SI will print that syscall. What if we just do set RIP equals here? And then step I? No, it still prints it. Help catch. Catch syscall. So, okay, let's start the program again. Info B, we will delete breakpoint 2, D2, info B, continue. What is RAX currently? So it's like it has completed, it's just not printing it to us. Okay, hold on. GDB catch points. Let's see what the docs have to say about this. It's making me feel like it's after, but it's not printing it to us. Like, catch syscall. So maybe catching the syscall in this way just like it's very confusing, right? Because it's why is it not printed to us yet, you know? Catch syscall. GDB catch before syscall. Okay, here's what we're going to do to test this theory. We're going to start the program up again. We're going to continue to this catch point, and we're going to set, so RDI is currently pointed at 1, so like standard out. Let's go ahead and set RDI equals 42 and step. See, it doesn't print out on standard out now, right? And if we look at RAX is not thrilled anymore. Right, so that just made it so. Here's what we're going to do. We're also going to start. We're learning something new with these catch points right now. So we start, we continue. So RAX is currently, it says it's this number. But I don't think that's true. Because if we step here, we get the hello world, right? Step gives us hello world. Start, continue. What if we set REX to like 0, right? Instead of, because right now theoretically we should be making syscall number 1 for right. What if we make it syscall number 0? Continue. Now that prints hello world. Okay, let's start it again. But we saw that if we change RDI and continue, that we don't get the output. Okay, so something's going on in GDB where it's not very nice to us. So I'm going to start scripting this to demonstrate GDB scripting. So if I code example.gdb, code server example.gdb, and we think about what are we doing when we run this. So we were running catch syscall write, right? And then we were, well, first we were doing start, then we were doing catch syscall write, and then we were doing continue, right? And so if I, or we'll just write C for continue. If I run gdb-q x example.gdb, /example, we see that we're currently in this catch point. If we continue again, we get this hello world. So let's continue one more time. And we're going to run this, right? We can see it prints hello world. And there's one more thing, if we never want an interactive shell, we can do --batch. And that will make it so it just runs our script, and then as soon as there's nothing left in our script, it exits. So it says a breakpoint when we start. So really, if we didn't want that either, I think, well, let's do it that way. So we set our breakpoint at main. We set our catch point, prints hello world, catch point. So there's, if we want to, for example, print RDI every time we're doing a write syscall, I can write this as follows. I believe this is the right syntax. So this syntax is a little weird. Yeah, so see, it prints RDI right here. So we see that that's RDI. And if we wanted to, actually, we can also do like printf, for example. So printf RDI equals, or even just say RDI equals %d, and we'll pass it RDI, right? So this says RDI equals 1, and then we probably also wanted the new line there. So RDI equals 1. Are we hitting this write syscall twice? Looks like we are. And if we wanted to view the backtrace each time, we could run bt in here. So I can see RDI equals 1. Here's my backtrace. So main called foo called puts. Main called foo called puts. Cool. So that is, we're starting to automate what happens when the write system call occurs. I'm wondering why we're hitting this twice. Oh, return from syscall write. So this is the call, so it is hitting both ends of this. Call to syscall write, return from syscall write. Okay, well, what happens? Why can't I do set rax equals 0, for example? Let's see, maybe I can. No, it's not really happy about that. Looks like we can't change the syscall mid-syscall. But we can change the arguments. As we saw before, we can change RDI to be equal to like 42. Oops. Why is that not copying correctly? Cool. Then let's get rid of this backtrace thing. So we set RDI to 42, and suddenly now we're not seeing hello world. I wonder if there's a way, catch syscall write start. Is that the syntax? Catch syscall start there. I'm trying to think, how do I set that I don't want this return thing? Whatever, we'll roll with it for now. So this makes it so we don't ever see the contents of this, right? So going back to this, like, how can I skip past a function call? So this is maybe a more complicated version of this than this needs to be. Let's say we have the scanf thing, right? So let's say we have scanf %d value. We have some value. We pass that. I think that's the right syntax. Hello world %d printf new line and value. Okay, so if we GCC this, GCC run example for hello world 4. Let's say we don't want to have to deal with the fact that I type like 55, right? The fact that I have to input something. I never want to have to input anything. I want like input to be automatic, let's say. Well, what I could do is that I could catch. So this was like the syscall variant of all of this, and we'll get rid of this part probably. Let's just get rid of that. What I can do is I can catch, or I can break on scanf. And what I'll do is I'll printf, let's just do this same thing here, or print RDI, and then we end, okay, and we'll run this. GDB. Okay, so we temporary breakpoint 2 at this, and it says RDI equals 1. When we break at scanf, I'm a little bit skeptical of that. Oh, I didn't say commands. This is why. Okay. Yes. Okay, so we can see we print RDI here. Okay, so we're setting up this catch point still just because we were showing that before. Maybe we don't care about that actually. We're breaking at scanf. We're printing the current context of RDI. We're printing it as a decimal. That probably doesn't make sense. Let's print it instead as a hexadecimal value, right? RDI is currently pointing at this. We're looking at scanf, right? We can even see here that format equals this same address ending in 46004, which is pointing at the string %d. So RDI is currently pointed at that. And if we wanted to, we could also, we could print RSI as well if we wanted to. Why is this? We'll do that. RSI, RSI. And we'll see, right, that we're currently hanging waiting for input. And the reason for that is, right, we're waiting for input. If I type 42 here, then it says hello world 42. I want to automatically, let's say in this context, send 42 or somehow get 42 in there without waiting for my input. I want to fully automate this. There's a whole bunch of ways to do that. In this case, let's go ahead and do this with GDB. What I can do is, let's go ahead and print 8 instructions here at scanf. So if I do this, I can see we're currently at the beginning of the scanf function. And ultimately, we're going on to call read, right? The read system call. We're going to read from file descriptor 0. We're going to read into this buffer. We're willing to read 1024 bytes. Scanf is calling read. Well, what I'm going to go ahead and do is I'm going to catch syscall read. And I'm going to execute some commands. So what I'm going to say is, well, hold on. Let's think here. There's a few ways to handle this. Before we go down this catch syscall route, let's show real quick that we could redirect dev null as standard in. Actually, I saw a question here. Do we have to have GDB downloaded separately, or when we connect to pwn.college via SSH, it's already available to use? Yeah, GDB is just installed on pwn.college. So let's, for example, redirect dev null here as our standard input. Okay, so now it prints hello world 0. And the reason for this is that the dev null is now our input instead of just our terminal. And so that scanf goes and it calls the read system call. We can see this actually if we wanted to. So for example, let's watch this read system call happen. So catch syscall read commands will print RAX, step instruction, print RAX, end. Let's see what happens. This is a different. Oh no, maybe this is correct. Hold on. Let's get rid of this. Let's see, when we're calling scanf, let's watch it call read from there. Let's get rid of this dash dash batch to make it so I can be interactive. Oh, this is a nightmare because we're redirecting dev null. Okay, no redirecting dev null. Actually, okay, maybe I did like this way before. Let's keep this catch syscall read. Let's just not redirect dev null for a moment. If we send an A, right, so we send A new line, and now RAX is 2. Not sure. What are print RAX step, print RAX. Okay, hold on. Let's refocus here. I feel like I'm out in the weeds. What the heck are we trying to do? Exactly. Now, you're not giving me a hard time. I'm trying to think about what the heck we're trying to do. But I couldn't get my GDB script to skip past the scanf no matter what. Okay. Okay, let's take this skip script to skip past the scanf no matter what. Okay, here's what we're going to do. Let's start fresh. Start fresh real quick. GDB-Q example, right? Start display 8i RIP. And we know very nicely, because we have the source code, but we can figure this out through the disassembly, right? That foo calls scanf. Let's just say this particular scanf right here. We're not going to be too generic here. We're going to say we want to skip this thing right here, this particular scanf. So if we disassemble foo, we're going to see, right, this scanf right here. We want to skip this thing. So at foo plus 46, we make this call. Okay. This is an objective we can work with. Okay. So we want to break, at foo plus 46, right? Break at foo plus 46. This is the location where we are calling scanf. And we want to do some things here, right? We want to run some commands at this location. Well, the very first thing I want to do, or one of the things I want to do, the obvious thing I want to do, is I want to skip past this. I want to set RIP to this address, foo plus 51. Okay, let's do set RIP equal to foo plus, let's make sure we got the syntax right also. So we'll do this. And let's go ahead and just run this now. Well, we're going to slowly build this up, right? I want to like skip past. So if I run example.gdb, undefined command, oh, not -ex, -x. Okay, and I continue. Where the heck am I? Foo plus 51. It looks like I skipped past it, right? If I continue still. Yeah, look at this. Okay, so there's one other thing I wanted to do, right? So this was the right syntax. I was unsure if we needed like a star there or something. Looks like this is good syntax. The next thing we want to do though, is we want to set RIP equal to this, and then we want to continue executing. So whenever we do this, whenever we hit this location, I want to move past that call. The way I move past that call is just set RIP. Instead of being at foo plus 46, let's go to foo plus 51. And then I want to continue. Okay, and then what else do I want to do? Well, I want to continue, right? So I start the program, I set up a breakpoint, and then I continue. Whenever I hit this breakpoint, I set RIP to this, and I continue. All right, let's see if this script works. And it does. Okay, so in doing this in this way, right, we're doing what you're saying. I want to skip past the scanf no matter what. This is us skipping past the scanf no matter what. Okay, and doing it automatically, right? Why do we omit the star though? It runs, well, maybe, good question. I don't have the answer for you. Looks like this also works, is what you're saying, and this is maybe a little more explicit. Good question. I'm honestly, I'm not sure what the heck's going on here. On why the star works with or without the star. Totally unsure of why it works like that. Yeah. It looks like both, what you're saying is both are supported. So let's actually test that. Yeah, both work just fine. Well, what happens with here? If I do that, or does that not work? I don't think that works, right? Yes, he doesn't like that. Unclear. I'm just going to straight up say unclear why, or what's going on there. This is some arcane GDB syntax on why we need a star here, and this star works with or without the star. No good answer for you there. Well, one other thing that we might want to do, depending on our circumstances, is maybe we want this not to print 0, right? We have this code here where we're scanning f%d, and we're just skipping past this instruction. Maybe we also want to set value to something, right? This is the semantics of this code is like whatever the user inputs, set value to that. Well, we could do that also. So here's how we would do that. If we disassemble foo, we're going to see that the second argument to the scanf, right? So this is going to be RDI, this is going to be RSI. So RSI is going to contain the address here of this thing. So it looks like right here, we can see RAX goes into RSI, and RSI is RBP minus hex 0. So if we look at this thing, if we look at this thing in that context right here, well, we're currently where we are here. Let's print it. This thing right here, before we set RAP and continue, let's print this. And we will do that. We'll see that this is pointing here. Well, like I said, that's that's the location. And what the heck is in there? Well, let's go ahead and XGX that thing. So this is the value. This is what's at that location memory. Represented as 8 bytes. I don't remember. Is this an 8 byte? This should be a 4 byte value, right? RBP minus x0. I mean, everything it says is a 64-bit value. Shouldn't really matter for us. We'll just treat it as a 64-bit value, but that could matter. We're going to see here, if we look at this, right? So this is that location in memory, and here's what it currently is. Okay, so now I'm increasingly skeptical. Let's go ahead and not call this a giant word. Okay, hold on. Let's think here. GDB uses giant words. What the heck is a thing smaller than a giant word? Why does everything have to have different names? You know, nothing's simple. All right, we'll just print it as 4 bytes, okay? 4 bytes, that's what we get. Because I can't think of what the heck's smaller than a giant word. Okay, 4 null bytes are currently there. I can change this, okay? I can not only set RIP, but I can set this location of memory. And here's how we're going to do that. This thing treated as a uint32t pointer. So let's treat this as an unsigned 32-bit value. And then, okay, syntax. GDB has some wild syntax. I think this is the right syntax for this. Let's say we want to set it to 42, okay? I believe that this is our syntax we want to go with for this. If it's not, I'm going to be very sad. Nope, okay, it worked. Okay, so what we need to do, I'm pretty sure if we get rid of that, it's going to say like, hey, I don't know what my type is. Yeah, I'm tempted to dereference a generic pointer. Issue is, right, it's similar to when we do assembly and we say like move RAX 0, right? Well, what the heck is 0? Is 0 1 byte, 2 bytes, 4 bytes, 8 bytes? And then we do like keyword pointer. Okay, well, similarly here, if we get rid of that, this is ambiguous. Like, what the heck is this 42? Or in this case, 42. What the heck is that thing? We make it unambiguous by casting it. So we cast it. I like this way of casting because everyone, for some reason, we gotta have giant words. Why can't we just have UN64s, right? It'd be so much simpler. A giant word, really? Like, I truly am sitting here thinking, what is one smaller than a giant word? I don't know what half a giant word is. Because we also have quad words. That's another thing that's equivalent to a giant word. I do know that half of a quad word is a double word. Because quad, double. At least that kind of makes sense. A giant word? What the heck is smaller than a giant word? Well, it's just a word? is a mess. It's a mess. It's a mess. This is my rant about anything other than just saying how many bits something is. All right, so we're doing this. We set it to 42, and it looks like it worked, right? It worked. Yeah. So this comes down to like, what are we trying to do? But if our goal is to kind of like automate this scanf, right? As in just like, let's skip it and let's mimic the behavior of it. This is what we can do. We can set up a break there. We can get rid of this. Set up a break here. We can change it so that RAP is pointing here. Really, the order of this doesn't matter because it's like the order just doesn't matter. We can change the value of this thing right here into value. We can change the value of it. Kind of complicated. Our variable name is value. We're changing the value of value. What a mess. But we can change that and change it to 42 and then skip past, as in go to this printf basically and continue. And ultimately, this is how we can do what you were talking about. Does this answer your question? I mean, I know you said you got the flag, but I couldn't get my GDB script to skip past the scanf no matter what. Is this the answer? Okay, awesome. Glad we were able to answer. It took a while. We were speaking too generally. As soon as we digged into what the heck we were trying to actually do. Lots simpler. Okay, does anyone else have questions about using GDB? Sounds like this has been a GDB office hours, which is good. GDB is a very, very powerful tool. And on average, like when you're using GDB, you're not even creating scripts like this. Like this is cool that you can do this. But even just the basics of being able to interactively use GDB go a really long way. I guess one other thing I'll show, something that was trying to pop into my head, is like, what if for some reason as part of our analysis, we don't want this to go to standard out, and instead I want this to go to like data.txt, right? This hello world 42, it's like an objective we could have. Yeah. Is an objective we could have is that instead of going to standard out, I want it to go to hello.txt. Now, of course, kind of the simple answer is, right, we just do this. Maybe. Hold on. I think we need to say, we need to do --batch. So like we could do this, right? But of course, this is a little bit different because this is printing like all the GDB stuff to us, right? Like what if we literally, just as an example, specifically wanted this text right here only to go to hello.txt. We wanted to like momentarily change where this printf is printing to. Okay, here's what we could do. Catch syscall right end. Basically what I'm thinking in my head, well, there's a few things we need to do. Let's say the very first thing we do after we start the program is I need to somehow get a file descriptor pointed at hello.txt. So we'll quickly do this. Well, one of the cool things I can do in GDB, except what the heck is going on here? Okay, one of the cool things I can do is I can use this call thing. And I can, for example, call open hello.txt. And in this case, we have too few arguments. Don't know if I can do this. No, we can't do that. But we can manually pass a 2 there. And you'll see we get 3 back. We just like called a function and just like got something back. And if I do info proc mapping, we didn't actually care about mapping, info proc, and I look at this, so ls al proc this fd, we will see that 3 is now pointed at hello.txt. We actually, when we called that, when we did that call, we opened this file. So that's really cool. So, and then that got saved onto $1. So if I do call open, what did I say, hello.txt? Doesn't really matter, whatever we're trying to call this thing. And I pass 2. And then I print $1. Cool. We see every time you print it, saves it to a variable, whatever. I wonder if I can do set fd. Can I do that? Print fd. Can I do that? No, we'll just use $1. I just sworn there's a way. If I do set fd. Can't remember how I save this to a variable. GDB scripting save value to variable. These people say that it's set. I feel like I just did set. fd equals that. I think it's that. We're going to try it anyways, though. What the heck is the syntax for this? Set $something equals to result of call. Okay, here's what we're going to do. I do this, and then I do set fd equal $1. What about that? Okay, that works. Whatever. Print fd. Cool. I don't know if there's a way to do this in one line, but we're going to roll with that. And then we catch syscall write commands set RDI equal fd, continue, and continue, right? So now, presumably this is, we're writing once, right? We're handling, every time we change, or every time we call write, just change RDI to fd. Let's see if this works. Oh, we lost our thing where we had our previous script that was doing this 42 thing. All right, let's see what happened. Cat hello.txt. rm hello.txt, touch hello.txt. Oh, yeah, it worked. Look at that. So if I do echo 17 to this thing, at hello.txt, we got our 17. So yeah, this is just like another demonstration of how powerful GDB can be, right? At the very beginning of our program, we can decide to open another file, save that off, and then anytime we do a write system call, just change RDI to be that thing. So now we're not writing to standard out, we're writing to hello.txt. It's just another example. Cool. All right, any more questions about GDB that people have? Very important to understand GDB. Even though we were struggling with GDB here, there's a lot to learn for mastering GDB. It's very useful to understand. So it allows us sort of like scripting and analysis, like an ad hoc analysis of some program, which you'll see as you go further into this reverse engineering module is very useful. At least it's a useful technique. There's a lot of techniques that come into play. How you want to do it is up to you. But GDB is very powerful and is one really cool option for you. All right, I'm not seeing any more questions. If we get more questions, feel free to ask on the Discord. I'm going to wrap up my office hours here. A little bit of a quicker office hours. We got a little lost in the sauce on GDB, but hopefully you learned something. And if anyone has more questions, again, feel free to ask on the Discord. Thank you and goodbye.